All right, first question actually doesn't have a specific answer. It could be sine or cosine depending on how you view this. My advice is always take a look at where is the point on the y-axis. If it starts at the maximum, then that's a very convenient cosine graph. If it started at the minimum, if the minimum was on the y-axis, we could call that a negative cosine because it would just be reflected. If it started at the midline, then that would be the sine. So my first answer to number one is I'm going to call this a cosine graph, but you'll see you could also call it a sine, and we'll explain why in a little bit. The next one, we're going to do a couple of things to my graph before I answer the next couple questions. What I would like to do then is kind of identify, okay, here's my max line. Right now, where is that max line? It's at the equation y equals 5. And then where's my min line? The minimum is at the equation y equals -3. So if I want to find the difference between those, right, what's the middle point of those? I'm just going to add them up and divide by 2, right? So if I want to find the midline is your max plus your min divided by 2. So that's 2 over 2, or 1. So if I go to y equals 1, there's my midline, and it's at the equation y equals 1. Now notice we asked for the equation, so you do have to write y equals. If you don't put the y equals, especially if this was a delta math problem, and you just put 1, you would get it wrong, right? Because when they say equation, there has to be a variable involved, so y equals 1. What is the amplitude? Well, the amplitude is how far up or down are we from the midline. In this case, they should be the same thing. How far did I go up? Well, 1, 2, 3, 4. And then how far did I go down? 1, 2, 3, 4. Another way to view that without a graph. Let's say I didn't even give you a graph and I asked you to find your amplitude. All you would do is take the equation for the midline and subtract that from the max. So 5 minus 1 is an amplitude of 4. And remember, the amplitude is always the absolute value of whatever the A is. That's going to come into play in a little bit. But my amplitude is 4. We already did the equations for the max and min, so this is really quick. What is the max? Notice it says equation. So this was a delta math problem. You would have to put y equals 5. And for the minimum, what's the min? That's y equals -3. All right, the period. What do we have to know about the period length? Well, the period length is how long does it take to complete one full cycle. So if I start at the max, how long does it take to get back to the maximum? And that's where you check your x's. I went from 0 to 2 pi. So here the period is equal to 2 pi. And then the hard part is write the equation for the trig function. So what we have to do is we have to remember first what form is that in. My pen is acting a little weird right now. And since I called it a cosine graph, I'm going to use cosine instead of sine. And then you have to remember which values were which. So now there's a couple of different ways to kind of think about this, but the way I think about it is the A value. Okay, well, the A value tells us the amplitude, but so I'm going to put 4, but I'm questioning, is it a +4 or a -4? And it all depends on where the initial value is at 0. Since this is up at the top of the maximum, then that's going to be a +4. All right, so we get y equals a +4. If it was reflected down here at -3 at a minimum, then I would put a -4 there. And then the b value, that's usually the hardest one to find, right? How do I find the b value? Well, the b value is determined by knowing the period. Okay? We know that our equation for any sine or cosine function is the period was always determined by 2 pi over b. Well, if the period is equal to 2 pi, I'm going to put 2 pi right here. It says 2 pi equals 2 pi over b. Now, since this doesn't deal with any negatives, I know my answer is going to be positive, so I'm okay just kind of removing the absolute value. Well, you can cross multiply and divide, or you can see that 2 pi over 1, the only way that I'm going to get 2 pi over here is if b is equal to 1. So somehow you have to do the algebra to find out what b is. All right, and then h is my shift, left or right. Well, notice cosine did not move left or right, so I'm just going to leave it as a 0. And then your k value is the midline. And we found up here that our midline was 1. We can see that in our graph as well. Okay, and then number 7 is kind of a challenge problem. We didn't really talk about that at all. So I was curious how you guys would do this. And since we know that our answer to number 1 could be sine or cosine, and the only way that it differs is if I shift one left or right. So watch what happens. What if I took this point right here? That's the midline, and I shifted it over a pi over 2. Well, wait a minute, that's a horizontal shift. That's an h value. So my answer to number 7, I'm going to do this right here, is I could actually change this to a sine function. B value doesn't change. The only thing that changes is this shift. And what did I do? I shifted everything to the left, pi over 2. So if I'm shifting to the left, remember how it's opposite of what we think? Now there's only one other thing here. Notice, if all this shifts, so I start here, then this point would shift over, this point would shift over, and this point would shift over, and then this point would shift over here. So my new graph would look like this. And I got to think, okay, that's definitely a sine function because it starts at the middle, but I didn't go up to the maximum, I went down to the minimum. So this 4 would have to be compensated by putting a negative there. So this is one potential rewrite of the function with a horizontal shift of sine. Okay, now that's not the only one. What if I wanted to shift everything all the way from 3 pi over 2, everything this way? Well, then that would make it a positive sign. So it'd be a plus 4 sine 1x to the positive 3 pi over 2. So there are multiple answers you could have for number 7. I just wanted to kind of show that to you. It's an extension of our learning. Okay, so here's what we got today. And I just want to, our goal today is to review for the Chapter 4 test. Now, if you've taken notes for every day, you have all this stuff, and you don't need to write any of this down. Actually, most of today, I'm going to tell you not to write anything down because we have all this in our notes already. But we have a test. Our test is going to be during class this Thursday, February 4th, and that starts at 9:30. You will have the class period to finish it. So if you're late to class, then you're cutting into your own time. So be on time. It is 50 summative points, and it's going to work roughly the same way the other tests have. You get 43 of those points for correct answers, and then you get 7 points for submitting your worked out solutions to Schoology. So you're showing your work for every problem that needs it. I know that there are some that don't need it, and as we review today, I'll just make note of this would be a problem that you don't have to show your work for. But basically for every problem that requires work, that's what we need to see in order earn the full 7 points. All right, there are 21 questions, and I know that sounds like a lot. However, some of them are very quick questions, and you'll see that as we review today. The estimated time, according to Delta Math, for this test is 30 minutes. So you have the entire class period, which is an hour and 15 minutes, and Delta Math says you should be able to complete it in 30. Now, some of that time is writing down your work and submitting it to Schoology, but just so you know, even though it's the estimated time of 30, you have the entire class period. What are the topics we've covered? Okay, finding reference angles, arc length. We're going to review this today because it's been almost a month, I think, since we've done it. Finding trig ratios using SOHCAHTOA and their reciprocals. Analyzing trig graphs, basically the warm-up that we just did. Right? Can you find the midline, amplitude, period, phase shift, vertical shift, max, and min? And then can you write the trig function? If I give you a graph, can you do what we just did in the warm-up and write it in the form of A, B, H, and K for sine or cosine? And then graphing trig functions, we would only do a sine and a cosine graph. We're not going to graph tangent or the reciprocals. That's something we decided we're not going to focus heavily on because of the structure of distance learning. Okay. Everything that we have here today, all of this stuff is going to be saved as class notes. So I actually don't want to spend a lot of time going over all this and having you guys write it all down. So here's what I'd like to do for the next handful of slides is I'm going to go over this very quickly. And my thought was I'll show you how I would do it. You watch. And then if you have questions, you're either going to unmute yourself and ask, or you're going to throw it in the chat. And I'm monitoring the chat as we do this. So then if you need more help on a specific topic, now's your time to ask. All right? So let's look at number 1. It says find the reference angle. What kind of work would I expect to see if this was a problem on the test? Okay, here's what I would expect you guys to do is draw the picture. 151 degrees is roughly like right there. And then we're asking for the reference angle, right? What is the reference angle? So I need to see this angle, and you could even draw in your reference triangle. But then to find the angle right here, the reference angle, what do? You take 180, because that's all the way to halfway around the circle, and you would just go 180 minus 151, and you would get a reference angle that's 29 degrees. Okay? And by the way, when you're showing your work on the test, I do need you to label the problem. So this would be problem 1, and then here's my answer. Okay? All right, that's the first part. Number 2, in a circle, an angle measuring pi over 2 radians intercepts an arc of 3 pi. Find the radius. So this is an arc length. What do I need to see from you? I need to see the fact that you know what the arc length formula is. And then you do have to remember, arc length has to be in radians. Okay, so if this was in 90 degrees, I would need to convert this. And that's usually where students make the mistake. Okay, theta is the angle measure, so this is really friendly. And now they give us the arc length. So arc length is S. I'm going to put 3 pi where S is. I have to find the radius, and I'm going to multiply that by pi over 2. So now my job is to just undo this. So if I'm timesing by a pi over 2 on one side, I'm going to multiply by the reciprocal of 2 pi to the other side. And notice how I'm not going to grab my calculator. I'm going to do 3 pi times 2 over pi, and that will give me r. Well, the pi's are going to reduce out. 2 times 3 is 6. And my answer is the radius is 6. And I'm going to read the question. They don't tell me the measure at all, so I don't know if that's inches or feet, but I just know it's 6. Okay. All right, now This one they kind of flip it around. It says find the radius is 6, and the angle intercepts the arc. So now they give us the arc length. So now we have to find the angle in radians. You got to make sure pi is in your answer for that one. So I'm going to say S is equal to the radius times theta, and we know that arc length is 1 pi. This time we know the radius, so now I have to go ahead and solve for theta. So if I divide by 6, I get 1 pi over 6 is theta, or we could just write that as theta is pi over 6. We don't need the 1 up there. And notice that is in radians, so we're happy with that. Okay, so right there, that's just arc length. Remember, the big thing is theta always has to be in radians. If they gave it to us in degrees, convert it into radians first before you work with the formula. All right, the next one. This one says, given tangent of angle A is square root of 95 over 7. Well, right away, when I see the word tangent, I'm thinking TOA, right? So I know the opposite and adjacent. And it says the angle A is in quadrant 3. So you got to know something about quadrant 3 to find the exact value of secant. I'm a visual learner, so what I would do is this. I would graph this first, and I'd say, here's quadrant 1, here's 2, here's 3, and here's 4. Now we know something about the sign values, right? Quadrant 1, x and y are positive because I move to the right and up. If I move to the left and up, that means quadrant 1 is negative, or quadrant 2, x is negative and y is positive. If I'm in quadrant 3, I moved over and down, then I know the x is negative and the y is negative, and that's the quadrant that we're focused on. So, what if I just drew a rough triangle? This doesn't have to be perfect, but I know I'm in this quadrant, and here's angle A. And according to tangent ratio, the opposite side is square root of 95, the adjacent side is 7. So what I need to do then is I'm going to have to find Pythagorean theorem to find the hypotenuse, and then I want to find secant. So I'm thinking, wait a minute, secant is the reciprocal of cosine. Right, so I think of it as 1 over cosine. Well, if cosine is the ka in SOHCAHTOA, if cosine is adjacent over hypotenuse, that means that secant is hypotenuse over adjacent. And notice, I have the adjacent, right? I found the adjacent because of the tangent ratio. That's 7. I need the hypotenuse, so I have to do Pythagorean theorem here. And the nice thing is the square root and the squared cancel out. We get 49. And they do say write it in simplest radical form. So when I add these together, what do we get? We get 30, 144. I believe I'm going to just double check my math here. That's 144. And then if I take the square root, the nice thing about this is that gives me a really nice friendly answer for the hypotenuse. So I would need to see some work like this. You picture how you found the hypotenuse, and then you got to answer the question. Right? Well, what is secant? Sorry, my pen is messing up today. Secant is the ratio of hypotenuse over adjacent. So, what is the hypotenuse? It's 12. What is the adjacent? It's 7. And I cannot reduce this, so the answer I would plug in would be 12/7. Okay? Now, if there was a radical on the bottom, let's say this is not the answer, but let's say that I had 12 over square root 3. right? That is not in simple radical form. So what you would have to do then is if your answer was like this, you would have to simplify by multiplying by the denominator. So I would get 12 square roots of 3 over 3. Remember, square root of 3 times square root of 3 is square root of 9. And then 12 divided by 3 is 4. So if this was my ratio, the correct answer would have to be simplified. Okay? So just keep that in mind, reading the directions very carefully. Okay. This one is very similar. It says theta is an angle in standard position, and its terminal side passes through the point. Now notice, negative and negative. Right away, I know that that value, that point, is in quadrant 3. And then they tell us to find cotangent. So I would draw a graph, and we know x, and we know y. Now, actually, you technically, well, I would still recommend doing this. I think the visual process is worth it. So here's your angle theta. We know x is negative 4 because I went 4 to the left and down 5. And then I got to find cotangent. So what am I thinking about cotangent? Well, cotangent is the reciprocal of tangent. And if tangent was SOHCAHTOA, O over A, then cotangent is A over O. It's just the reciprocal. Now notice, I have everything that I need here. I don't need the hypotenuse, so I'm not going to find it. I have the opposite, and I have the adjacent. So what is cotangent? Cotangent of theta is the adjacent over the opposite. And then you should reduce this. I'm not sure how delta math would, I think it would accept that if it was a negative over a negative, but we know that a negative divided by a negative is positive. Okay. So in this case, you don't need the hypotenuse because cotangent doesn't involve hypotenuse. And again, if you have any questions, please throw it in the chat or unmute. I'm doing this purposely pretty fast so you guys can have some time to work today. All right, find the exact value of all 6 trig functions at pi over 6. Now, first thing I'm thinking of is, wait a minute, okay, pi over 6, what is that in degrees? Well, remember, pi is the same as 180. So in my head, I'm thinking, well, 180 divided into 6 equal chunks is 30 degrees. So this is the same as 30 degrees. Now, technically, you do not have to draw this picture, but I'm making reference to the unit circle. You're really going to have to use your imagination on that circle. But what I'm going to do is I'm going to graph where would the 30 degrees be? And then what is the x and y value, right? And there's a couple ways to do this. In the unit circle, this is the longer side, and the longer side was a square root 3 over 2, and then we went up half the value. Notice, this point right here is half the value to this point, which was 0, 1. So if I go up half of 1, that tells me the y value is 1/2. Now, unit circle, here's x, here's y, or as we learned, it's cosine and sine. So however you want to think of this, but I want to set up my 6 trig functions, and I recommend doing it in this order. Sine, cosine, tangent, and then their reciprocals. And this is the way my brain works. If I take the reciprocal of tangent, that was always cotangent. If I spell cosine backwards, it kind of looks like secant. And then the one that's left over is cosecant. Okay. Well, you have a couple ways to write your answer now. Right? If you were to set this up, you could use our special right triangles and do SOHCAHTOA. Or we know that the sine value is always y over 1. Or in this case, what is the y value? It's 1/2. You don't have to divide by 1 because that dividing by 1 doesn't change anything. But notice, if I know sine, then all I'm going to do is flip this upside down, and 1 over y is cosecant. So if I flip the answer, I get 2 over 1, or in this case, just 2. Okay? And then we know cosine is the x value, which officially that's x over 1, but we're just going to call it x. So here's my answer for the x value at pi over 6. Right? I should say. And you know what I should have done is this should be pi over 6 for all these thetas, but we know that theta is pi over 6. And then what happens if I flip this? Well, secant is 1 over x, which is the reciprocal of our answer. But this gets to that point, we don't like the square root in the bottom, so I'm going to rationalize that. And I'll get 2 square roots of 3 over 3. Okay? And then tangent is the tricky one. Tangent and cotangent. Tangent is the sine over cosine. So it's y over x. Now, I'm going to do some side work here. What if I put y over x? If you do this enough, you know the 2's are just going to reduce out. But as you're still learning it, we're remembering I do not like to divide by a fraction here. What I like to do is multiply by the reciprocal of this value. And when you do that, notice the 2's cancel out, and I'm left with 1 over square root of 3. Now, I'm going to write this here, even though that's not my answer, right? We don't like that square root in the bottom, but why do I want to write it now? Is because I have to take the reciprocal to find cotangent, which is x over y. And the fact that I have this written friendly, if I take the reciprocal of that, then that just gives me square root of 3 over 1 or square root of 3. So I don't have to deal with the rationalizing it here. All right, and then the final piece is we don't like this answer right here. So we just have to multiply by the square root of 3 top and bottom. And when I do that, I end up with 1 times the square root of 3, which is just the square root of 3. Square root of 3 times the square root of 3 is square root of 9, or 3. Okay? So you should be very familiar with finding sine, cosine, tangent, and its reciprocals using the unit circle. All right, we're almost done. This is very similar to the warm-up we just did. The only difference is there's no graph. So I want to show you, you might be able to do this in your head. Find the minimum and find the maximum. Well, the key is what do we know about the k value, right? In this case, k is -3, and that's my midline. Now, I'll show you this graphically just really quick. Where would we be? Here's my midline at -3. Right? And then we know that the absolute value of the A is 5. Well, that's my amplitude. Right? My amplitude tells me to go up 5 from the midline and down 5. So the question then is, where is the min and max? We're 5 above this, so what is that? Well, if I take -3 and I add 5 to it, that puts me right at +2. And then what if I'm at -3 and I subtract 5? That puts me at -8. So I now know, just from looking at this, I don't really need a graph, but you could sketch one if you need it, The minimum is at the equation y equals -5. Oh, sorry, -8. And the maximum is at y equals 2. Okay? So I would recommend drawing a graph here if you need it, but you don't have to. All right, the second one, what's the period? Well, the period is based off of the b value, and the b value is the number in front of the x. Okay, and we know, because this is a cosine function, that the period is equal to 2 pi over the absolute value of b. That's the equation that we need. Well, I'm going to plug 5/6 right in here. Oops. Let's do this. Now the absolute value just says this is positive, so I'm not too concerned about the absolute value, but I don't like to divide by 5/6. So I'm going to take that 2 pi, and instead of dividing by 5/6, we're going to multiply by the reciprocal. And nothing reduces out top and bottom, so we're just going to multiply straight across. 2 pi times 6 is 12 pi. 1 times 5 is 5. And that cannot be reduced, so my period, it will take 12 pi over 5 to go from a maximum back to the maximum again. And notice, we already did the work for number 3. Where is the midline? Well, the midline is whatever your k value is. That's your vertical shift up and down. So the midline is at the function y equals -3. And why is it? Because your k value is the midline. Again, if you have questions, I'm going pretty fast, but let me know. Okay, well, what if I asked you the same thing, except for now, I give you a graph. So I don't give you the equation, and actually you're going to have to write the equation. It's the same work. So actually, why don't you do this? I want you guys to try this problem. I'm going to do my work here, and then in about 4 minutes, we're going to go over it. So go ahead and try this problem right now. So find the midline. Well, what I'm going to do is I'm going to think of, if I have a graph and my max is 1 and my minimum is -3, you want to find the minimum value of that. Now mathematically, you could take 1 plus -3 and you get -2 and divide that by 2. You're finding the average value between the max and min, which is -1. But if you have a graph, you can also just put that line in there and count up to and down to, and notice that that fits right in the middle. So more than one way to do this, but my midline should be at the equation -1. I'll show you that in a second. The next thing that I did was I determined the period. Actually, I think I can go. So I put this, here's my midline right at y equals -1. That's the k value. Then the period length, this is the way I view period, is if I start at a max, how long does it take to get back to another maximum? That's one full period worth for this function. Well, notice I go from 0 to 5 pi over 3. So there's the period. Right? We know the midline. And then the amplitude can be found from the midline. How far up did I go and how far down did I go? Well, I went up 2 and down 2. So the amplitude, which is the a value, and I'll explain why it's positive in a second, but the a value is 2. Now the hard part about this is I have everything they asked except for writing the equation. To write the equation, I need a, b, h, and k. So let me show you what I did here. I took the fact that I knew the period was 5 pi over 3. And I said that's what the period is equal to. So 5 pi over 3 is equal to 2 pi over b. And since they're positive, the absolute value sign kind of goes away. Then if I cross multiply, I get 5 pi times b equals 6 pi. Divide both sides by 5 pi. The pi's reduce out. Oh, thank you, Z. And let me go back. I forgot to unshare my screen. The video was going, but I forgot to unshare it. So thank you for that. Let me just quick show what I did. So my max and my min, and your value has to be right between it, right? That's your midline. And we talked about how you could find that algebraically is take your max plus your min and divide it by 2. That's finding the average of that. Sorry, my chat just disappeared. There we go. And then the amplitude is 2 up from that or 2 down from that, right? That's how I get to a max or a min, as I go 2 units above the midline. So that's the A value. We'll talk about why it's positive in a second. And then we found that midline to be right here at y equals -1. So now this is what I was showing you before. The period is equal to 2 pi over b. The period we know is 5 pi over 3, and that has to equal 2 pi over b, and that's how we're going to find the value b to write the equation of the line. So then I'll cross multiply. Nothing special. 5 pi times b equals 6 pi. Divide by 5 pi, the pi's reduce out, and I get b equals 6/5. Okay, so notice the period helps me find b, the amplitude is the a value, the midline is the k value. So the only thing I have to think about is between a, h, and k, and b, what is the one that I don't know? It's h. Well, this is where you get to choose. Okay, and that's the thing that a lot of students don't recognize is pick the one that's easiest. Look at where we start. If we start at the max, now when I say start, that's when x is equal to 0. If I start at the max, then this is a positive cosine value. So it's positive, which means the a value is positive. If I started at the minimum, if the start was down here, then the a value would be negative because that's just a reflection. So what do we know? We know a is 2. I found the b. That's the most amount of work you're going to have to do for a problem like this. The h is 0 because I'm starting right at cosine. And then the k is 1. That's your midline. So we did the warm-up. We did a problem like this. Hopefully you're feeling more and more comfortable with that. Basically, this is the same thing. We're not going to do this problem, but notice if I gave you, write a cosine function that has an amplitude of 3, a midline of 4, and a period of 2/5. The only thing you would have to do is cross multiply. You know what? Maybe I'll do this one quick because I'm halfway there. You don't have to write this. And then if I divide, I get b equals 5 pi. Now notice, a, b, k, they don't tell me I have a shift. So I know it's a cosine function. Now I'm just going to plug in what I know. A is 3. The b value we just found is 5 pi. You could write it as just x, or you could put x minus 0, but since there is no h, I'm not going to put anything there. And then the k value went up 4. And there you go. We're done. Now notice, I could also ask you a question like this. What's the max value? Well, here's the midline at 4, and I have an amplitude of 3. The max would be at the equation y equals 7, right? Midline plus the amplitude. And then what would the min be? Well, the min would be your midline minus the amplitude. So 4 minus 3 would be 1. So we can ask you questions about that once you know it. All right, last problem, and then you guys are going to have about 20 minutes of work time. I'd like you to try this one. I'm going to give you a minute. Evaluate, using the unit circle, no calculators, what is cotangent of 5? Quick, I'll share with you how I would think of this. So I see cotangent right away. And this is what I'm thinking. From the unit circle, we know that tangent of any angle was sine over cosine, or that was y over x. Well, in this case, cotangent is the reciprocal, so x over y, which means I need to figure out where is 5 pi over 3. Well, if I'm thinking of this in terms of thirds, right, this would be, pi would be 3 pi over 3, and 2 pi all the way around the circle would be the same as 6 pi over 3. So that just means 4 pi over 3 would be somewhere right here, and 5 pi over 3 would be somewhere right here. So I'm going to draw in basically my angle, and then I'm thinking of my reference angle, right? How big is this piece right here? Well, this piece is a third left, right? Because if I go from 5 pi over 3 to 6 pi over 3, that's 1 pi over 3. Or you could say that's 60 degrees. If that helps you, that's 60 degrees. But really, I'm concerned with what is the location of this point. Well, I go over half the distance. Notice, even with a poor graph, you can see this goes over halfway. So I went 1/2 to the right, which is positive. And then I'm going down the long way. So that's negative square root 3 over 2. And there's x, there's y. Cosine over sine is cotangent. So if I do 1/2 divided by negative square root 3 over 2, the 2's are going to cancel out. We know that. But if you're not sure, you can times by the reciprocal. And there you'll see the 2's reduce out. Then you're left with the answer that we don't love because the radical's in the bottom. So I'm just going to multiply by square root of 3 top and bottom. And I get square root 3 over 3. And I like to put the negative up top. It doesn't really matter. But that's your answer, negative square root 3 over 3. Okay. All right, so here's the expectation for kind of the rest of today, this hour, and then your homework tonight, as well as Wednesday. So today, Miss Dwyer, you know what, I'm going to put this video for Wednesday because I don't have it up yet. Miss Dwyer made a video that we're going to have you watch, but I'm going to have that on Wednesday. So here's what we got. Tonight, you have the review. I sent you an email about that. It's in Delta Math. It's optional, but we want you to try one problem from each category because there's like a good amount of problems on there. Now that is an optional assignment, but you know that if you do that work, it will help you for the test, which is this Thursday in class. There isn't any new homework other than watching the graphing reciprocals functions. And I just want to let you know that this video is just to make you aware that the reciprocal graph functions of sine, cosine, and tangent, they have graphs as well. It's more of just watch it to gather your information. We're not going to test you on the reciprocal graphs or tangent, only sine and cosine. All right, so if you go to Delta Math, this review should be available right now. And you can start working on that. And then on Wednesday, I'll have a video posted for you to watch. Do remember that if you get one problem done, from each category in this review, that's a automatic 70% on the test. Right? So if you do that, you're guaranteeing yourself the minimum of 70%. All right, that's all I have. You are free to leave Zoom. If you have any questions,